Okay. Discuss with your classmates. Oh, good thing you brought it up. How you might graph the relations that are given here. They didn't really give me a rule. They didn't give me the set of x comma y such that. They just listed a bunch of points, right? And so, I don't know. I can start plotting those points. Did anyone do that? Anyone start plotting the points that were listed? Oh, that's not enough. Tell you what, take a piece of graph paper and I'll give you 1 minute to plot as many as you can. And please talk to someone next to you about what might be another point on that, in that relation. Let's go. You know, number 40 I think is a beautiful problem. Anyone notice any patterns about the points in number 40 or the numbers in number 40? Mario?
For the x-axis, it goes in numerical order.
Yeah.
Backwards, and for the y-axis, it's exactly next to numerical order.
What do you mean?
Like, first one is
Plus 1, plus 3, plus 5. Hey, does anyone have a prediction what the next one would be? What would the next point be to the right? 416, because if you add the 7 to the 9, that's very interesting, right? You guys see the pattern Mario's talking about? He's saying that the y's are increasing by a little bit more each time. As I go from here to here, the x increased by 1, the y increased by 1. As I go from here to here, the y's increased by 3, the y's increased by 5, and so the y's would increase by 7, and you get 416. But it's interesting, because I've seen a number of you that are like, I didn't see that, but I see how to get 416. What's another way people are doing this? Go ahead. Y equals x squared. A little rule, right? I mean, negative 1 squared is 1, 2 squared is 4, 4 squared would be 16. Two completely different ways of looking at this problem. They didn't tell me that y equals x squared is the rule, so I don't really know if that's it. But it says, hey, the dot, dot, dot means the pattern continues. Hey, by the way, does that always work? Does that pattern always keep you in the relation y equals x squared? Yeah? How do you know? Okay, I could square 100. So how would I do that? To square 100, I know 100 times 100 is 10,000, right? So I guess my question is, if I started here at 0, I add 1, then I add 3, and then I add 5, and then I add 7, and I keep going until I've added 100 odd numbers to that thing, am I going to be at 10,000? A lot of people are believing it, and a lot of people are saying, well, how the heck would you know without actually doing it? And those are deep mathematical questions, okay? Kind of beyond what I want to do. But it's not that I don't want to ask them. Anyways. 1.3. Oh, does it say that? You guys getting something like this, by the way? By the way, if I were to graph the equation y equals x squared, do you remember what that looks like? Oh, we talked about that. What is that? Then I'd be allowing all kinds of points, including the fraction inputs. And what shape is that? That's a parabola. And we'll talk about those later. Oh, it shouldn't be dotted. I guess I made it dotted because I knew you guys didn't really have any fraction inputs in problem 40. And so I was just kind of saying, well, what if this were the case? Because you're right, we don't normally do that. Okay, chain it.